Alright, so today we are going to find the slope of a tangent to a polar curve. So last class we graphed all sorts of polar curves. Now we're just going to find the slope of a tangent line at any point on this polar curve. So you should be copying down this formula, which in a normal AP testing world you would have had to memorize. But you don't have to memorize it now. And really and truly remember, the point of this is so that when you get off in college and you're taking Calc 2, that you've seen this stuff before. Because as you all know, the more you see of something, the better off you understand. And so it's just better to see it now. So dy dx is equal to dr d theta sine theta plus r cosine theta all over dr d theta cosine theta minus r sine theta. So really and truly, with this section, we only have two examples because all you're doing is plugging it into the formula and evaluating it. So you know your unit circle, you're good to go. You will have to do some simplifying. That might take a little minute, but we will simplify together. All right, let's look at number 1. Example 1, you're going to find the slope of a tangent line to the polar graph of 2 sine theta at theta is equal to pi over 3. So what I like to do is first plug it into my formula here. dy dx is equal to dr d theta. So the first thing you got to do then is you got to figure out what dr d theta is. So r prime, or dr d theta, is going to equal, what's the derivative of sine? And that's going to be cosine. So you've got 2 cosine theta. And then you want to figure that out at pi over 3. So 2 cosine of pi over 3. Well, cosine of pi over 3 is equal to 1/2. So it's going to equal to 1. So we have 1 sine of pi over 3 plus our r. Now, let's evaluate this r at pi over 3. Well, the sine of pi over 3 is the square root of 3 over 2. So that's just going to be the square root of 3. R is equal to the square root of 3. Cosine of pi over 3 over r dr d theta, which was 1. Cosine of pi over 3 minus that same r sine of pi over 3. Okay. Now, your final answer should be negative the square root of 3. Why don't you take a minute, push pause, see if you can simplify this to be just negative the square root of 3. Alright, so now I'll do it. So sine pi over 3, the ones, who cares? Sine of pi over 3 is square root of 3 over 2. Cosine of pi over 3 is 1 over 2. Okay, then cosine of pi over 3 is 1/2. And sine of pi over 3 is the square root of 3 over 2. Okay, so there I've gotten rid of all the trig values. So this is square root of 3 over 2 plus the square root of 3 over 2. So that's going to be 2 square roots of 3 over 2. Okay, where of course those can cancel. So really it's just the square root of 3. This denominator is going to be 1/2 minus, well, square root of 3 times square root of 3 is just 3. So 1 minus basically 3 over 2 is going to be a negative 2 over 2, which is just going to be a negative 1 as well. So you end up with just negative the square root of 3. Okay? So that's the answer for number 1. So now, why would you have to go all the way? Well, you do need to practice with your algebra. Also, this would have been a multiple choice type question. So while you would have needed to plug things into the formula, you can't just stop here. If it were free response, which it wouldn't have been, you could leave it there. You'd have to evaluate the trig, but getting the practice with the extra math, always good. All right, let's look at example 2. Example 2, let's say I gave you that r is equal to 1 over theta, and that theta is equal to 3, and we want to find the slope of the tangent line when theta equals 3. So dr d theta, I'll have to take this to the top. So this is basically theta to the negative 1. So I get negative 1 theta to the negative 2, or negative 1 over theta squared. Now, if I'm determining that at 3, that's going to be negative 1 over 9. Okay? All right. And then r at 3 is going to be 1/3, because if r is 1 over theta and you plug in a 3, then it's going to be 1/3. So dy dx is equal to your dr d theta, negative 1/9, times the sine of 3 plus your r, which is going to be 1/3 cosine of 3, all over your dr d theta again, cosine 3 minus your r, sine of 3. All right, now things to remember. You can't cancel those things. You can't cancel these things. You've got pluses and minuses going on. So things cannot cancel. You also can't necessarily leave it like this, okay? We need to simplify it. Now, we don't know the value of sine 3, and we don't know the value of cosine 3, so we wouldn't be expected to do those because they're not on the unit circle. But we would be expected to kind of simplify this stuff. Remember, we don't like fraction over fraction. So look at the numerator. The best thing you could do is you could get a common denominator so that we can keep change flip. We can't keep change flip right now with a plus and a minus. So let's go ahead and get a common denominator so we can keep change flip. So if this we're having a denominator of 9, we'd have to multiply both top and bottom by 3. So we'd have a negative sine 3 plus 3 cosine 3 all over 9 divided by, now if we wanted these to both have common denominators, you'd have a negative cosine 3 minus a 3 sine 3 all over 9. Now, if you were to keep change flip, those 9s would then cancel out. So your final answer would be negative sine 3 plus 3 cosine 3 on the top, and the bottom would be a negative cosine 3 minus a 3 sine 3. And you can't go any further than that. That would be your simplified version. I suppose if they didn't want the negatives out in front, you could divide each one by a negative, but you know, you're still going to have a whole bunch of negatives everywhere, so it doesn't really matter if you're pulling out the negative or not. You would just be able to leave it like that. All right, so that's really it. It's just plug it into the formula, and then just from your formula, the practice of reducing. So when you're working on your homework, plug things into the formula, that's fine, but then just practice reducing and make sure you're getting your answer to where mine is. Okay? All right, the next section. The next section is find the arc length of a polar curve. Okay? Now, the first thing you have to do is determine your theta intervals. Okay? You're either going to have to look at the graph, or it will be given to you. Okay? And we'll talk about the two different things that go on there. Sometimes you have to look at the graph, and I'll show you how you do that. Sometimes it's just given to you. Now, number 2, it's going to be a formula. L, your length, that's an L, is equal to the integration from alpha to beta of the square root of r theta squared plus r prime of theta squared. Okay. Now, what we're going to do is we're going to do all of these by hand. So we're not going to be using our calculator. Why? Well, in the first one, we're going to have a letter, so the calculator won't work for you. The second one, we want our answer to be specific. Okay, we don't want our answer to be just some decimal. We want it to be in radical form or something like that, which a calculator can't do for us. So we have to go ahead and we have to do all of these by hand. Not exceptionally tricky, because you can simplify them down to make the integrations not so hard. All right, we have 2 examples of these as well. So example 1. So we're going to find the arc length of the entire circle of r is equal to 2a sine theta. Okay. Now, I don't know the intervals for 2a sine theta, and I've got this a here, so I don't even know the exact, graph of this thing. But when I'm graphing this thing, I need my chart, just like we did before. So I go to my quadrantals, and I'm going to graph 2a sine theta. Now remember, sine starts at the origin, so it's going to start at 0. Then it goes to its amplitude. Well, its amplitude in this case is 2a, so 2 times whatever a is. Back to 0, negative amplitude, back to 0. Now, I don't know what 2a is, okay? But I know that it is some positive constant number, okay? To be honest, I think they really would have to tell you that it is a positive. So where a is greater than 0, okay? Because if it were negative, that's going to change where your circle is, and if it changes where your circle is, it'll change your intervals. So we're going to say where a is greater than 0. So we start at 0, then 2a means that it's going to go in some positive direction, because we said that a was positive. Then back down to 0, then back. Now, negative means we're going opposite of the 270, which means we're going right back up here, and then 0. It's right here. So our circle is somewhere in here, between 0 and pi. Okay? So our circle is found all within the 0 to pi range. So our L is going to be equal to the integration from 0 to pi. Now, we'll figure out what we're going to put there in a second. Our theta is 2a sine theta. So if we're squaring 2a sine theta, that's going to be 4a squared sine squared theta. Okay, so we want to think about that. Then we have to add it to the derivative squared. Well, what's the derivative of 2a sine theta? Well, the derivative of sine is cosine, so it's 2a cosine theta. This is r prime. And we want to square that. So that's 4a cosine squared theta. Don't forget your squared. 4a squared. Now look, you've got a common term. So you can pull out a GCF. That GCF is going to be 4a squared. So if you pull out a 4a squared, you're left with sine squared theta plus cosine squared theta. Well, what's sine squared theta plus cosine squared theta? Well, that's just 1. So you've actually done the grunt work before putting it into this formula. The formula says the square root of r squared, so there's our r squared, this is our r, plus r prime squared, this is r prime, we squared it. We simplified it down to be just 4a squared. So we're going to integrate from 0 to pi the square root of 4a squared d theta. We can simplify that even more. The square root of 4 is 2, square root of a squared is a. So you're integrating 2a from 0 to pi. Now, look, it's d theta. So it would be like if you have 5 dx. The answer would be 5x. This is 2a d theta. If you integrate that, then it's just 2a theta. So it's 2a theta from 0 to pi. So you plug in the pi first. 2a pi minus 2a times 0. And you get your final answer to be 2a pi, because 2a times 0 is just 0. Now, let's talk about different intervals, just as a side note. If your circle had been over here, okay? If your circle had been over here, you're going to want to go from negative pi over 2 to positive pi over 2, okay? Negative pi over 2 to positive pi over 2. You don't want to say that it's 3 pi over 2 to pi over 2 because 3 pi over 2 is bigger. Remember, you got to go smaller to bigger. So think negative pi over 2 to pi over 2. If you were over here, think about what you would do. You would start with a positive pi over 2 and you would go this way to 3 pi over 2. Okay, because you'd be going this way. This one, you're going this way. So you have to kind of think about how you are going to pick the intervals that you're doing. And keep in mind that it has to be from smaller to larger. Okay, so it's got to go from the smallest thing to the largest thing. Now, could you do 3 pi over 2 and then, oh, whatever that is, if you go further in something bigger? Yeah, sure, but then you got to figure out what that is when you get bigger, which isn't too bad, but why would you mind? I think it's, what, 5 pi over 2? So you could do 3 pi over 2 to 5 pi over 2. I do believe that would work. Use your calculator. Check it out if we ever get to that option. And I'm doing it in homework. Check with your calculator to see if your answer matches mine. All right, last one. Number 2. All right, so R is going to equal E of 2 theta. And we're going to go from theta equals 0 to theta equals 2. Okay. So I told you where we're going, from 0 to 2. So we already know that we're going from 0 to 2. So R squared, that's going to be, let's do it like we did before. We had R was E to the 2 theta, and we want to square that. So it's E to the 4 theta. R prime, that's going to be E to the 2 theta times 2. So that's going to be 4e to the 4 theta. So when you're adding that together, 1e to the 4 theta plus 4e to the 4 theta is 5e to the 4 theta. So we're integrating from 0 to 2 the square root of 5e to the 4 theta. D theta. Okay, now to integrate this square root of 5, it's a constant. I'm going to pull it out. And then I'm going to square root e to the 4 theta. So the square root of 5 is going to come out. The square root of e to the 4 theta is e to the 2 theta d theta. Now, e to the 2 theta, I have to do u substitution. U is 2 theta. Du d theta is equal to 2. So I'm integrating e to the u du over 2. So it's going to be 1/2 e to the u. So I get square root of 5 over 2 because of this 1/2. And then it's e to the u. And I want to evaluate that from 0 to 2. So plug in your 2. Square root of 5 over 2. E to the 2 times 2 minus square root of 5 over 2, e to the 2 times 0. That is 0. Well, e to the 0 is just 1. So our final answer is going to be square root of 5 over 2, e to the 4 minus square root of 5 over 2. Make sure that that square root of 5 over 2 doesn't disappear. You plugged a 0 in up here, but that didn't make that entire thing 0. So this right here is your final answer. Now, could you pull out a square root of 5 over 2? Sure, you could. You could do the square root of 5 over 2 times e to the 4th minus 1. That would be a fine answer too. So if you were doing a multiple choice type thing, you'd have to look for both of those on there. Okay? So really and truly, today's lesson was just 2 formulas. Formula 1, finding the tangent line of a polar curve. And then number 2 was finding the arc length of a polar curve. You just have 5 homework problems, and that's it. It's just practicing using these 2 formulas and practice the simplification, making sure that you're getting my answer by being able to simplify algebraically. All right, great. Have a good day.